I'm Stephen Foskett, the organizer of Tech Field Day, and we're here in Austin, Texas for Tech Field Day 13. I'm joined today by Robin Systems and a group of invited delegates from around the world. They are to ask questions and participate in the discussion. If you'd like to learn more about what we're doing, go to techfieldday.com, and you can find more videos like this at youtube.com/techfieldday.
I'm actually going to use a couple of applications that I guess some of you may be familiar with. These are called VDBench applications. They actually write incessantly to disks. It's like it shows that it's continuously generating IOPS, read or write on a specific set of LUNs. So what I have done, I have created a couple of these applications, and you can see the IP addresses here. The first VDBench application, this is the IP address, and then it is running on Canon 6. And we also, they are the other application, the other VDBench application. Actually, let me go back, and we can see that it is also running on Canon 6, and they are hitting the same disk. So just to simulate that we have two competing apps. And at this point, if we go to this QoS window, there is no constraint set on these applications. They will just create as many IOPS as they can on these set of disks. So what I'll do is I'll go to the console, and I will actually get from my history itself. This is basically a command for VDBench, which means that create random 4K reads, hit this LUN, and elapse for 1,000 seconds run, and it's completely a read-only workload. 100 means read-only, and that rate max means create as much IOPS as possible. So I do the same. I will start this workload on this one, and then go to my other VDB1 application, and open the console, cd VDBench, and on this one as well, this is exactly the same application. I start the same workload. So right now, the workload is going to create about 30,000 IOPS. You can see out there. And let me check if I have the QoS. Okay, I had this, so I make sure that I have both of them have the right settings, and I need to open up another Robin window so that I can show you what's happening on the host Canon 6, because they are both running out of Canon 6. So I'll go to Canon 6, and by the way, look at the consolidation density now. It's increased from 1.33 to 3.67 because we have been adding more and more app throughout this, demos. So I will go to my infrastructure, nodes, pick up Canon 6, and two lovely colors, purple and orange. The purple is the VDB2, and the yellow is the VDB1. So this is the sort of the pattern that we see here. So what I will do is I'll split the screen. Actually, I need to split it, bring it here. And let's say you think that VDB1 needs to have
Deba,
more.
Can you
I'll actually do is
wider view.
This one and this one. You have some wider, whatever we can squeeze in. So let's say your VDB2, just assume VDB2 is my more critical application right now. If I look at this, they are each creating about 32,000 IOPS, total of 65,000. you want to make sure that my VDB2 app, my VDB1 app, which is my less critical application, to not get more than 6,000 IOPS. Let's say 5,000 IOPS. So what do? You go to this QoS screen, and you basically say that bring the read IOPS for VDB1 down to, what's it, 6,000 I said? 6,000. And when I hit apply, you need to look at that screen on the right side. It is squished down to, on this part, you can see, I follow my mouse pointer. Now, I do see that approximately it's getting 6,430. There is some always little bit here and there, but
I think you specify 6,500.
Oh, did I specify 6,500? Okay. So, and we can also go back to these, so now you can see where we are. This is the IOPS. Just by a click of a button or a slider of a, moving the slider, we could control. So this is my max IOPS, the noisy neighbor problem. One application is creating a lot of IOPS, noise. I want to reduce it and give the rest of the bandwidth to my other app, and I had actually done that. So now let me reset it back. Hit apply. You will see on the other side that magically this changes from 6,000 to 25,000 because I just changed the control. So this basically shows you how easily you can control IOPS between two applications. Now, what I'll do is we have a total. So now this, you can look at the chart. It has come back to the same. Both of them have equal distribution. So let's say both of them are getting about 25,000, 51,000, or so. Can I try to make one of them? Let's say this time I'll make the VD1 and tell it to have its minimum IOPS to, let's say, 31,500 or 31,000. And if I hit apply, you will see now the blue or the purple one will be squished down, and the yellow will get more, because I have now said that this VD1 application, come what may, doesn't matter. I will do 31,000 IOPS, guarantee 30,000, 31,000, if the application requires, of course. You're doing less, it's fine. If it requires, it will do. So you can see definitely the purple one has reduced, and it has given the yellow one more bandwidth because we have told Robin to give the yellow application a guaranteed minimum of 31,000. So that is, the mean and the max demonstration. Now, I want to talk about, in this context of this QoS, Oracle, when we talk about consolidation in Oracle always pitches the Exadata appliance as a solution for consolidating Oracle databases. And one of the features that they talk about is I/O resource management. I/O resource management for Oracle databases is only available on Exadata. But if you run your databases on Robin, you could actually get the same I/O resource management out here without have to paying for an Exadata-like appliance. We actually provide this. So these can be two of your Oracle databases, not just these VDbench. It is the same for, as I've been saying, the same for any application. Yes.
Are there any other features that you're bringing from the Exadata platform into Robin, which will allow your customers to invest?
So that is one of the things that we bring in, definitely the QoS feature. Another feature that a lot of people use Exadata for, they would consolidate many databases and run on the same compute nodes. That's what we called in Exadata. Now, in Robin, you could do the same using containers. The problem with Exadata is that there is no physical isolation in the memory and the CPU. I mean, Oracle provides instance caging and SG allocation, but they are all actually running out of the same host. If you give root access to one DBA, he gets access to all the databases because there is no sharing, it's one server. With containers, you can provide access to specific databases. So that is, I think, is a huge thing that nobody is actually, probably a lot of people are asking, but nobody is getting from Oracle on that.
Do you have current customers who have made a purchasing decision on your platform based on those features?
We are working with an Oracle customer at this point in time. They like this thing, but you understand we are a very young startup, so we are working on.
Totally understand.
Yes.
Yeah.
So these decisions take time, but there are other customers who are working on Hadoop space, HBase, customers on Elasticsearch. We are working on an opportunity on Cassandra as well. We have a lot of very, very good Cassandra-specific features, which are, really good. Yes.
Are there any other features or gaps that you have identified in Oracle and Exadata, and it seems to be something you have expertise on, that you would love to see your customers embrace in this platform?
Yes. So one of the things that I do think that I spoke about the cloning feature. The other thing that I cannot show you today, but if needed, I can get back to you. We run inside a container. So if the host goes down, what happens to the container? We have failover capability. So the container fails over to another live node, and it just starts working from that node. So those type of, Oracle makes your customer pay for rack 1, all these type of high availability features. You have to pay a lot in order to get those features. But in our platform, it's just built in. So, yes.
Have you had any challenges or opportunities with the Oracle sales reps competing against you, and then
so
trying to work for you?
we anticipate to have those sort of challenges, but we'll see what how to deal with that when we come across those. So I actually think, yeah, go ahead.
I was going to say you mentioned failover, which just sort of triggered something else. How do you guys handle potential split brain situations? If you have this container is your failover, you lose your link or you lose your communication between them. So, this becomes your failover node now, but this guy's actually still up trying to manage the same containers. How would that, or do you have something in there to prevent that?
So when we fail over the container retains its IP address. So we use our own, the Open vSwitch networking that actually helps retain the IP address of the container. So in a span of a second, when the container is back up on the other node, the application won't even realize that it actually has gone down. I don't know if I've answered this question.
Maybe I'll add a little bit color to that, right? So we do have, if you remember the architecture diagram that I had, right? So we have this notion of a 3-node manager cluster, which uses a Paxos-like algorithm to make sure that there is consistency. Now, that cluster is used in a way like a tiebreaker. So when nodes go off, or they get repartitioned, they check. Each node, of course, checks whether it is part of a quorum number of nodes or not. If not, they will commit suicide. Or, the consistency over availability, right?
I like it.
If partition is going to happen, C or A, you have to choose one of the other, right? So, or what we do is that if the node is available, the container has gone down. Before we bring it up on another node, we do a bunch of checks to make sure that it's not already running somewhere else. And then when we are certain about it, we bring it up on another node.